starting today, we get into kind of more the bulk, the focus of this section. And so if you are like gone tomorrow, watch the video. And guys, there is no other way around this. You have to try them. There is no steps to get to the end. It's not a, hey, follow A, B, C, and it solves it for you. I'm going to give you suggestions, and a lot of it relies on you being able to kind of remember algebra rules and apply them to trig-looking functions, because it does not change whether it's an x or a sine of x. They are the same rules that we have had. One of these shortcuts that I want to help you with that can save us a little bit of time deals with your reciprocal identities. If I want to move something in a function, when I move it to the other part of the fraction, it can just be the reciprocal function. For example, if I look at something like 1 over cosecant x, and I'm going to put some stuff around it just to not look like it's disappearing here. Like if I had like a, I don't know, a cosine x here, maybe a cotangent x sitting over here. But if I wanted to move just that function to the top, when you move it to the top, there is a long route or a short route. As it moves to the other part of the function, it is just the reciprocal. And so if I were to move that cosecant up to the top, it would look like a sine of x in the top of my fraction. Very similarly to the idea of if I move a variable raised to an exponent, it changes the sign on the exponent, right? So if I were thinking about something like 2x squared y to the negative third, and I drop that y to the negative third to the bottom, that's the same thing as 2x squared over y to the third. And we can move things in our fraction by just changing the sign on their exponent. It's the same thing with your trig identities. You can move it to the other part of the fraction by just using its reciprocal. So like I could move that cotangent up to the top, and instead of writing it as cotangent in the top of the fraction, it would look like tangent. It's reciprocal. Whatever its reciprocal is, you can move it to the other part of the fraction and write it as that. So that's a little bit of a shortcut for you. But remember that if it is multiplication, it is not attached to whatever it is multiplying forever. So if I wanted to move that secant of x, I could drop it to the bottom of that fraction. The 5 is not attached to it, though. So that 5 would stay there, but if I drop the secant of x to the bottom of that fraction, it would become what? What's its reciprocal? Cosine. Those are the same expression, okay? And for different reasons, we would want to move things around a fraction. A lot of times trying to get it to say sine or cosine, and that's just a kind of a shortcut instead of having to go the longer route to get that accomplished. Any questions on that? We don't really need that page right now. What I'm going to do is basically remind you of a whole bunch of simplifying things that we can do in algebra, and then kind of try to bridge the gap between that and what it's going to look like in trig. Okay, so something like simplifying a fraction. Numbers are not going to change. It doesn't matter if there's a trig function after it or not. If it's something like a 6 over 18, remember those are just numbers, both divisible by 6, and I could simplify that into 1/3. But variables raised to an exponent follow a different rule, right? If I have an x cubed over an x to the first, what do we do with the exponents? We subtract, right? So I would subtract 1 from 3. There's still 2 x's up here. And this would simplify down into an x squared over 3. We can do the same thing with trig functions. If it were to be something like a sine cubed of x over a sine to the first of x, very similarly, they have the same base. We can subtract their exponents in a fraction. What you need to be careful of, so I would be left with a sine squared x, is wherever that is, if we were to have flipped that, sometimes people will say that this, okay, I can eliminate that and I get sine squared x. What mistake did I make? Should be a 1 over. Happens a lot, okay, so make sure that wherever your bigger exponent is where your answer ends up, right? That should have been a 1 in the top, even though I crossed everything off, it's still a 1. Other algebra rules. Remember that if we have things attached by addition or subtraction, that is the strongest bond in math, and you cannot break a plus sign, right? We've talked about multiple times this year, although it is tempting, I cannot just cross off the x's. Don't put that in your notes. That's wrong, right? I cannot simplify the 6 and the 2. Unless I find another x plus 6, it stays an x plus 6 forever, right? Same thing with trig. We will see things that are tempting, like a sine of x plus 1 over a sine of x minus 1. You can't cross off the sine of x's. They are attached by addition to something, okay? Now, with that being said, if I were to find the same thing, I can cross off that whole expression. Like in this, we will be looking for GCFs. We'll do that again today. If they have something in common, you can factor a GCF out. We will see that same idea today, factoring out a GCF. Also, if we have an expression that matches an x plus 2 and an x plus 2, those do simplify. And you can take that whole thing out of there. Same thing, but instead of an x, say sine of x, you can do that same idea. Our last one will be more what we see tomorrow, but if you ever have a fraction with a monomial denominator, it came from adding two fractions together that had that common denominator. And guys, the idea of common denominator is going to become huge over the next couple days. Whether we are putting things together or taking them apart, it all is based off of common denominators dealing with fractions, right? Well, I could break this fraction at that plus sign and give them both back that common denominator and call this instead x over 2 and 4 over 2, right? Likewise, putting fractions together, I have to have a common denominator before I can add those numerators together. Now, we're going to kind of transition all of those algebra ideas into trig functions. The hard part is I can't really tell you where to end, which we'll talk about here in just a second. But all I'm going to do today is give you a bunch of strategies to try, and you're just going to have to trial and error them a little bit. Here's your first strategy. Turn anything that is not a sine or a cosine into a sine or a cosine. So replace with identity to make, I don't like how this. How about write all as sine or cosine? Okay. Reason I say write all as sine or cosine, if it is already a sine or a cosine, don't change it, but one of our options is go through and replace these. Okay, so what do I mean by that? Look at your identity sheet. It says cosecant on there, and there is a place where it says cosecant equals something in terms of either a sine or a cosine. 1 over sine. So I could rewrite this as 1 over sine. Tangent, same thing. Now, tangent's on there a couple times. It says 1 over cotangent, but that is not sines and cosines, is it? So pick the other option. Tangent is also what in terms of sines and cosines? Sine over cosine. So this is a strategy. And it is my strategy that I will say, if all else fails, you are looking at a problem and you have no idea how else to start it, this is my suggestion. Try writing things as sines and cosines and see if anything happens, okay? Well, we're multiplying. Key is multiplying, right? When multiplying, we can cross off things that match in the top and the bottom, right? Because I'm just going to multiply straight across the top, straight across the bottom. And I could be able to cross off those signs, leaving me with 1 over cosine of x. Now, and we're going to talk more about this on the next page just to remind you. But as we look at this, when am I done with a problem? Ultimately, we want to get a couple things accomplished. If I can get to just one trig function or just one number, you would be done. But we also want to eliminate all fractions. So with that being said, yes, I have one trig function here, but can I rewrite that as something else and not have a fraction on my answer? Secant, right? 1 over cosine could be written as secant. And now it is one trig function, not a fraction. Ultimately, that would be what we're trying to get to. To simplify. It is going to ask you to simplify, and that's what we're going to talk about on the next page. That's going to be your directions. Simplify, and that becomes very big. Okay? So, with this being said, if it is already a cosine, don't change it. If you're trying out the strategy of rewriting things in terms of sines and cosines, if it's already a cosine, don't change it. Don't go now change it to 1 over secant. Okay? If we're trying out the strategy of sines and cosines, leave it as is. This would be 1 over, and we already talked about that, sine of x, right? Everything can look like a fraction if I put it over 1. So now sometimes it bothers people if it's not. So I multiply straight across the top, straight across the bottom. Nothing cancels this time, right? Not one trig function, and it's still a fraction. Give me an option. Cotangent, right? If I look at my identity sheet, cosine over sine is cotangent. That is the same thing, but now it is completely simplified into one trig function, not a fraction, okay? Now, how did I know to keep going when I was at this point? Guys, that's the hardest part about this section, is I cannot tell you on every problem when to stop. And I can't tell you how many times people are going to ask me that. How do I know when I'm done? You don't. You will know when you're done on, I would say, the majority of our problems, especially here at the beginning, when we are down to one trig function and not a fraction, okay? Or one number and not a fraction. The problem is not every problem out there can get that far. So there will be a couple problems that we will have multiple expressions left over at the end, and you can't get it any more simplified than that, and it'll just take trial and error to learn at what point we are done, okay? So in my opinion, that is one of the most challenging parts of 5.1 is I can't tell you when to stop. Hopefully we get to one function and then you know. So I will give you strategies today to try out. I will give you more strategies tomorrow to try out. And then we will continue to have conversations. And again, a hard part about this section is there's not just a singular way to attack each problem, but we all should get to the same point at the end. Okay? So my first suggestion is to replace things that you see in your function with identities. Now, I would be slow to replace everything. Sometimes people see problems up there and they just replace all functions, okay? First of all, if it is already a sine or a cosine, I would really hesitate to replace it. It's not saying that you won't ever, but I wouldn't replace it immediately. This one I put up here because I want you to look for something very specific to show up in our problems. Anytime we have something, let's write squared up here. Squared, if we have some squared term plus or minus either another squared term or 1. If that ever shows up in our problem, something squared plus or minus, okay, and the order does not matter. I need you to look at your identity sheet to check out to see if it matches a Pythagorean identity. Okay, for example, in this one, we have something squared accompanied with a plus or a minus. When that happens, go to your identity sheet. Now, be careful about the order that those things are written, but on your identity sheet, do you guys see a 1 minus sine squared? Okay, and what does 1 minus sine squared equal? Cosine squared, which means I can take this out and replace it with what it equals. This is all multiplication, right? And all multiplication means I get to multiply straight across the top, straight across the bottom. And this is what we kind of previewed earlier today. If I have a cosine of x in the bottom and a cosine squared in the top, I can simplify one of those from each of those places and be left with cosine x. This is going to happen a ton. Something squared plus or minus. If it doesn't have the plus or minus, probably not a Pythagorean identity, but anytime it has a something squared plus or minus, check it out. Try, okay? Questions on that? Strategy 2, common denominator. This is the first of our conversations about common denominators, okay? And this common denominator idea is going to show up in a ton of different formats over the next couple days. This is going to just kind of start us off here. So it always has to be kind of an underlying theme. And as you think about like our reciprocal identities, our quotient identities, all of those are fractions, and we're going to end up with tons of fractions. And I keep saying the words common denominator, and if you look at the example I have on the board, there are no fractions. There, yeah. I can make it a 1. or I can replace it with its identity, right? So again, as we use multiples of our strategies, one of our strategies is writing things as sines and cosines. Cosecant, 1 over sine of x. So if I were to go through this problem and replace my terms that are not currently sines and cosines, we start seeing fractions, right? So cosine is cosine. I would not change that. Cotangent, cosine of x over sine of x. So if I just go through and change it into sines and cosines, I now see fractions, and now our conversation about common denominator is going to make more sense. When you have two terms separated by a plus or a minus, a common denominator is frequently what I will suggest you try out. A lot of times we want to get it down to one term, meaning we got to put things together with a common denominator. Well, ours already has a common denominator. Guys, order of operations, by the way. I can't put those together before I do the multiplication, right? Multiplication and then addition, subtraction. So as I multiply straight across the top, straight across the bottom, when I take cosine of x times cosine of x, yeah, think x times x, right? Not 2x, x squared. Same thing with your trig functions. Cosine times cosine, cosine squared. 1 times 1 is sine of x. Now, this one has a common denominator to start with. So I can put these two fractions together just like with a common denominator. If I were to have something like 3/7 plus 2/7, they have a common denominator. You keep the common denominator and just add the numerators. Same thing with your trig. Common denominator, we keep the common denominator, add your numerators together. And this is where our layering is going to come into play. I got to keep thinking about other strategies. I told you on the last page, look for anything squared plus or minus as a trig identity. Those are going to show up a lot. 1 minus cosine squared, sine squared, right? So I can replace this numerator with sine squared. And again, simplify my fraction, leaving us with just sine of x. And again, as soon as I get to one trig function and it doesn't look like a fraction anymore, we're done. Questions? Okay. My last strategy for you guys today, and then we'll practice a few and then we'll add some more strategies tomorrow for different types of problems. My last strategy for you guys today, again, since we're kind of going through the whole look for sines and cosines thing, if we were to attack this going into sines and cosines, before you start trying to put things together, I would simplify my fractions. Okay? For example, in this one, we have everything but this term already in sines and cosines. So maybe I start by just changing tangent to sines and cosines. And this is where we got to remember our identities here. Tangent is sine over cosine, right? I would not change anything over here yet. Maybe eventually, but not yet. I can multiply here to get that to be one fraction, except for, as I multiply, my cosines disappear, right? Could I have simplified this cosine with this cosine? No, I can't do that across a plus or a minus, right? Only a multiply. So we would be left with sine of x minus sine of x cosine squared x. Okay, so kind of a new strategy for us. If you have two terms separated by a plus or a minus, like we do, think of it like something like x minus xy squared. There's a GCF that we can factor out of that. Reminder on factoring out GCFs, right? They both have that same term. I can pull that out front. It's like you're dividing each of those by the GCF. And when you take something out and that's all that was there, it's a 1. Same thing's going to happen here. They both have a sine x. I can factor a GCF out. If I go back and then divide by that GCF to see what I would have left when I factor that GCF out, sine x over sine x is 1. I'm stressing that because a lot of times they think if I pull that out, it's gone, and I don't put anything there. But it really is 1, right? So that if I distributed that back through, we would get that sine term back. Minus cosine squared. Do you think that's going to show up a lot? Yeah, all the time. So 1 minus cosine squared, sine squared. And again, just as I kind of continue likening this to algebra, that's like an x times an x squared. What do you get? Sine cubed. That is one trig function that is not a fraction. That is as simplified as that is going to get. Okay? Now, I just told you that this one was, I put up here as an example of a GCF, right? Go back to the original part of this, and I very obviously led us in a direction over a different direction. But did anyone notice that there was a GCF at the beginning of this problem? Now that I'm saying GCF, do you see that there is a GCF at the beginning of this problem? Could we have started with that? Absolutely. We absolutely can start with it. So if I were to kind of show that here, it does look a little different. I would factor a cosine out of each of those terms. And this is going to be very important. We'll retouch this on the next page here. But I would want to get these to be one term. They're separated by a plus or minus. I would want them to get a common denominator and add them together. Tangent is sine x over cosine x, right? If I wanted to add that to this, its current denominator is a 1. The common denominator between those two terms is going to be a cosine x, isn't it? So I would multiply this by cosine x, top and bottom, which would give us that common denominator, and cosine times cosine is cosine squared. So that's one way I could get a common denominator there, which means now I can put them together. Sine minus sine x cosine x squared over the common denominator. Okay, well now I have a fraction times a fraction. Cross off my cosines, and we are back to this step. Sine of x minus sine of x cosine squared of x. So would it have hurt me in the long run to have done that first? Not at all. We will get the same answer. So all I'm saying is, as long as what you are doing is a legal algebra maneuver, try it out. See where it takes you. Don't stop until you have one trig function or you have now tried a whole bunch of things and it's not simplifying any further. Okay? So I'm going to kind of sum up and give you some ideas. I really want you to think through these three things as you attack your problems because it is not obvious on every problem. So things I'm going to leave you with. Don't replace everything. But I would suggest trying out putting in sines and cosines in your problem. Okay? So just a reminder, that is one of our strategies. Replace things with sine and cosine. But if it is already a sine, leave it. Right? So I would only replace the cosecant in this problem when I was simplifying it. If I replace everything, a lot of times I'll lose what could have simplified. We have not seen this, but in this problem, my sine x's both cancel. What am I left with? 1, right? I'd have a 1 in the top, a 1 in the bottom, and 1 over 1 is 1. And you absolutely can have a number answer. Typically, those numbers are going to be 1, -1, or 0. Great. That means I know I'm done because I'm down to one number. Can happen. Every now and then we'll see like a 2 or something. Those just don't happen often. Next problem. Remember that if you have something squared plus or minus 1, something else squared, whatever it is, Pythagorean identity, right? But you need to be careful. This is also something that's going to frequently happen as we get going into our Pythagorean identities and we go too quickly. If you look at your identity sheet, it has this, but it says that sine squared of x equals 1 minus cosine squared. Aren't those very similar? But exactly the opposite sign. When that happens, I can always factor out a negative to switch the signs on everything so that it does actually correctly match my identity. So if I need to switch the signs, just take a negative out. The 1 becomes positive, the cosine becomes negative, and now it matches my identity correctly, which means it would be a negative. Replace this with sine squared. Okay, so if your signs are opposite, take out a negative. That'll happen every now and then. And the last thing is, if you have two separate terms, get a common denominator, something like this. When they are separated by a plus or a minus, we don't get to just cross off, right? That I would make it look like fractions. If I wanted to add or subtract two fractions, we need a common denominator. Common denominator is going to be sine of x. I would multiply by sine of x. So that would give me 1 over sine x minus sine squared over sine of x. Now that I have a common denominator, I can put those together. That obviously would not be done. We would continue moving on to your common or your Pythagorean identity. The conversation for finishing this problem would be for another day. There are actually two 100% correct answers to this. One of those would be to just slide that sign up to the top so it doesn't look like a fraction. We don't want a fraction. If I slide the sign up to the top, we would write its reciprocal up there. Cosine squared x, cosecant x. Okay? Any questions? All right, your assignment is a worksheet today.